Hello. In this video, we are going to learn more about API gateways. So, if you have been building backend systems for a while, you have definitely heard about API gateways. Maybe even have used one like AWS API gateways, Kong, Nginx, or APG. But uh, here's what most videos don't tell you. An API gateway is not just a reverse proxy with a fancy name. So when API gateways are used correctly, it is one of the most powerful architectural decisions you can make. But when you use it wrong, it becomes your biggest bottleneck. So the bottleneck being a single point of failure, which is disguised as a feature. So in this video, we are going beyond the basics. We look at what a gateway actually does under the hood and the real problems it solves and the ones it actually introduces, and also see how production systems handle those trade-offs. So let's get into it. This is an architecture of API gateways. Let's picture this. It's 2012 and your team just moved from a monolith service to microservices. Now you have like six different backend services like auth, users, payments, orders, notifications, search. Let's focus on three services, which is auth, users, and orders. Now, for example, your mobile device or the mobile client now has to hit auth to validate the session, and it should hit the users to get the profile data, and it should hit the orders to fetch the purchase history. That's three round separate round trips and three sets of TLS handshakes and three services your client has to know about. Now you multiply this across web, iOS, Android, and third-party integrations. This is a like maintenance nightmare. Usually in the professional world, this is actually called as chatty client problem, and it's one of the core reasons the API gateway pattern emerged. Why the API gateway patterns emerged? So what actually happens is the gateway solves it by giving every client a single entry point. It gives a single entry point here. As you can see, it's only the single entry point. Only one host name, one TLS termination, and only one place to send all the requests needed. But what it does inside the entry point is where things get interesting. Start. Now let me break down the real responsibilities of a production level API gateway. First one is the authentication and authorization. This is the most critical one. So every request that comes in needs to answer two questions. The first one being, who are you? And the second one is, are you allowed to do this? Doing this inside each microservice means it is a duplicated logic, inconsistencies, and there are security gaps. So the gateway centralizes this. In practice, the gateway validates a JWT or it calls an auth service and attaches the decoded identity to the request, say a header, and it passes downstream to everywhere. So these backend services trust that header and they do not revalidate. This is called perimeter security, and it's the standard pattern. One gotcha here is if your service are directly accessible directly without going through the gateway, your security model breaks. Your internet network must enforce that the backend services are never exposed publicly. The next responsibility, a major responsibility, is routing. This is gateway's bread and butter. The request comes in, let's say, as post V1 orders. The gateway has a routing table. So the gateway knows this and it maps to the order service at some internal hostname. Now, in this case, the routing can be simple, like just a path-based matching, or it could be very sophisticated, like content-based routing, A/B testing routing. So this is all information respect to request routing. There is another important feature or responsibility that the API gateways take is transformation. The clients and service often speak slightly different languages. A mobile client might send a lean payload, and the backend might expect extra metadata, a correlation ID or a tenant ID or a device type. So what happens is the gateway, the API gateway can add or strip these details and give it to the service, making it a clean transfer or transformation of metadata. Also, from the security standpoint, rate limiting is one of the biggest feature of API gateways. Now, instead of adding rate limit for each and every service, we could centralize it. So when a single bad actor or an accidental traffic spike won't take down your entire system. So these are some of the roles and responsibilities of the API gateway. Now we are going to look at the problems with API gateway. The first is the gateway becoming a God object. So every team wants something from the gateway. The auth team wants to add token validation logic to the gateway. The platform team wants to add rate limiting rules. The security team wants to add WAF rules. And the product team wants to add AB routing for the new feature. The 6 months later, your gateway config is like thousands of lines of code. Nobody fully understands it, and every deployment requires a coordinated change from 4 teams. So the gateway starts pulling in responsibility it shouldn't own. So this is one of the biggest problem of API gateways. The second important drawbacks of API gateways are contract dependency issues. Usually, APIs are considered as contracts. So if the API changes, the gateway must be updated and it must require redeployment. So this leads to tight coupling and deployment delays. And the next most important thing is the frequent restarts. So if any service changes, the gateway must be restarted. This will cause a lot of downtime and frustration. But these are all fine. But the most important drawback of API gateways are single point of failure. So what is single point of failure? If your gateway goes down, everything goes down with it. This is not theoretical. It has happened at major companies. Multiple gateways, instances, or a load balancer or a circuit breakers could be added in order to solve this issue. But even with redundancy, a bad gateway config deployment can take everything down. So now let's uh, let's trace a real request end to end. So this all clicks. So the user opens the app, types a search query. Here's what happens. The client resolves API dot let's say yourapp.com into a IP address through DNS. In production, this is Route S3 or Cloudflare DNS, which has a low time to live because to introduce fast failover. Now, if the request is for static content or cacheable API response, it is served from the REST CDN, like images, videos, or any of that sort. This can handle up to 80 to 90% of read traffic without even hitting your origin. The non-cached requests can will head to the load balancer, hit an L4 or L7 load balancer. This is where the TLS terminates and the load balancer distribute across your gateway fleet. Only after this, we will enter into the API gateway, where auth, rate limiting, routing, request enrichment, and correlation of IDs are injected, and all the metrics are emitted. After the API gateways, it is um, it is reached to the microservice. The request hits the target service. The service may call others internally, but that's service to service, not through the gateway. The response. After that, it travels back through the gateway, which may transform it back to the client. So this is how a complete full request journey takes place with architectures using API gateways. Amazing. Now, at a high scale, a centralized gateway pattern cannot be used frequently because of its limits. Enter the service mesh architecture. Instead of one central gateway, every service gets a sidecar proxy, a lightware process which is running alongside it. It handles routing, MTLS, retries, and observability at the service level. The advantages is there is no single bottleneck. We won't experience any single point of failure. And you also get fine grained traffic control. But what is the cost? The operational complexity. Running a service mesh is really expensive. So this is the complete information on API gateways. Now we are going to take some final principles and call it a day. So the gateway usually is an infrastructure. It is not a business logic. The moment you start encoding business rules into your gateway, you have created a hidden dependency that will haunt you. The second one is centralized cost cutting. Auth, rate limiting, observability, routing, these belong in the gateway. Everything else belongs in the service. And you need to treat the gateway config as code. You need to version it, review it, or test it in staging. And a bad config push is as dangerous as a bad code push. And you need to design for failure. Your gateway will certainly go down. So multiple instances, circuit breakers, and graceful degradation are the most required things that you can do at a production scale. And the last and the final principle we need to take care is don't build what you can buy. So services like AWS, API gateways, Kong, Nginx, and APG These tools are battle tested. So building a custom gateway is only feasible when you have a specific requirements these tools can't meet. So yeah, uh, these are some of the things, complete information about API gateways. The goal isn't to use every feature a gateway offers. It is to use the right features for your architecture and at the right time with clear understanding of trade-offs. So if this gave you a sharper mental model uh, with the toughest gateway problem you have run into production. So yeah, thank you.